Hello, everyone. Welcome to All Things Aviation and Aerospace. I'm Vince Mickens with the Private Air Media Group. And my goal every week is to provide our aspiring young aviation and aerospace professionals with a glimpse of the possibilities, the opportunities, and your options in aviation and aerospace. If you like what you're seeing and hearing, please let us know by subscribing to the Private Air Media Group YouTube channel and/or Facebook page. I'm also on LinkedIn, Instagram, and Twitter. I feel so modern when I say that. You know, when I was a kid watching the Apollo space program blossom and hearing Walter Cronkite talk about it, it was a big deal back then. I see all of our younger viewers going straight to Google saying, yeah, I heard about the Apollo space program, but who's Walter Cronkite? Also, as a kid, I was into model airplanes, model rocketry, and you had two ways, I should say, to control model airplanes. It was a wired way. That'll really take you back. That's very early days of model airplanes. And then there was the with a wired, I should say, it was pretty limited what you could do with that little model airplane. But when we got to the radio controlled era, that changed things a bit, and your maneuverability was only limited to the sophistication of your controller. I'm sure you guys remember that. On the model rocketry side, think of a roll or tube portion of a paper towel, but narrower, and some balsa wings and plastic parachute, and a kind of a fireworks style rocket motor that had to be ignited with a 6-volt battery. A few days ago, Kyle, we were talking about that. Fun stuff. Great stuff. But back to radio-controlled model airplanes, I was pretty excited when I saw the first iterations of a radio-controlled model helicopter. I thought that was pretty cool. And of course, in recent decades, particularly in the last 10 years, the conversation in technology has been about drones, with various terminology like unmanned aerial vehicles, unmanned aerial systems, etc. And in just a few days from now, we will witness a historic flight of an unmanned helicopter, basically a drone, fly on another planet. That kind of puts us diehard aviator types in full geek mode. I know I've been watching it daily in terms of what's been happening. But it also made me seek out expertise in the unmanned aerial system world. Now, full disclosure, I would have loved to have had somebody from NASA JPL who's actively working on Ingenuity, Mars helicopter, but they're just a little busy right now, so preparing for that first flight. However, I was able to grab two very experienced experts who will not only be able to talk about the technology and application of unmanned aerial systems, but enlighten us about the opportunities, give us some insight on operation and regulatory challenges, explain the human interface of UAS technology, and what it means in terms of exploring on other planets, but even bringing it back home right here on Earth, the things that we can do with unmanned aerial systems and vehicles. Without further ado, let me first start out by introducing Dr. Scott Burgess. Dr. Burgess is an associate professor for the College of Aeronautics, Department of Flight with Embry-Riddle Aeronautical University worldwide. Dr. Burgess is also a U.S. Army veteran helicopter pilot who served for 27 years. Thank you for your service. His areas of expertise include rotorcraft safety, flight operations, unmanned systems flight and operations, and I could go on with that list. Welcome to the show, Scott.
Thank you. It's good to be here.
It's great to have you here. Appreciate you taking the time to be with us. We also have Kyle Snyder. Kyle is a Robotics Program Manager at Cherokee Nation Strategic Programs. He's going to tell us what that all means and what that's about. For the last 20 years, Kyle has been researching, developing, testing, educating, and integrating advanced aviation and unmanned system technologies. So as you can see, both of my guests have a great deal of background and expertise in what we're going to talk about today. And we had a chance, the three of us had a chance to talk a few days ago just to kind of catch up and talk about what we were going to do. But in that conversation, Kyle, you were on your way to launch a couple of model rockets. And I thought that was pretty cool because you don't hear that. As a matter of fact, because of COVID, I think maybe the activity was a little less than what it would be, because not far from us in one of the fields at a park here, used to see a lot of model rocketing activity. But it was neat to also hear that your son is kind of following in dad's footsteps and interested in some of the same stuff.
Oh yeah, no, he enjoys it. It gives us a chance to get outside and just see science in action, see what really cool stuff. I saw the first space shuttles launch from my backyard. We can't really replicate that from here in North Carolina, but being able to go out and throw things up in the air gives us a chance to get as close as we can. And we're going to do that for another party here coming up soon and get some of his buddies engaged too.
Sure. So with what you guys do, what's your take on what we see about the happening? I mean, this is kind of a very unique and very special event that's going to happen on Mars, to see basically a helicopter drone flying autonomously on another planet. I forget how many miles away.
Long way. Well, I think that it's fascinating and understandable why JPL folks and NASA folks aren't here, because you know that they're wearing off the front edge of their seat for about the last year plus, waiting for this to happen, and with the challenges involved, with the atmosphere the way it is, and the lift factors that are involved in that atmosphere, we're all pensively waiting for that successful first autonomous flight that's been programmed into the aircraft, and that really first test run. It'll be fascinating to see it. It's exciting.
Yeah, and Scott, so you come from flying helicopters. I mean, you flew as a career in the Army. Tell us a little bit about your getting into helicopters and how your perspective as a helicopter pilot with what's about to happen.
Well, for me, it was as a young kid, not going into college right away. I joined the Army, enlisted in the reserves, and got a ride on a helicopter. And really, that focused me for the next 30 years.
One ride, that's all it took, huh?
One ride, I was hooked. Good old Huey. But getting into that would lead me to where I'm at today, 22 years with Embry-Riddle, of actually then bringing that to other people who are just as interested in a similar part of their life that I had experienced when I was a young kid. And it's always fun to me to get fixed wing students coming into my office at the Prescott campus when I was running the helicopter program, saying, I'm not sure I want to be an airline pilot, because, you just get your coffee and set it on the panel and hit a button and it goes. I really want to fly. And I said, well, then let's get you into the helicopter and you can figure it out for yourself. They'd always come back and get into that program. And it was really fun to get young people interested in that aspect of aviation. And now that we're going into the autonomous world, once we kind of master the advanced air mobility or urban air mobility, then we'll start seeing sized uncrewed aircraft that are going to be able to take humans on an aerial taxi. I don't know that the humans will necessarily want to do that right up front, but I think that once we prove that it works, it'll be quite fascinating to watch. And we're right at the precipice getting ready to do that. So
yeah. So one of the things that they talk about with the Ingenuity Mars helicopter is having something like that when you're exploring another planet. So when we do finally send astronauts to Mars, they would be able to send that helicopter ahead that can then send them back information about what it's seeing, so that they kind of know what they're dealing with around the corner, so to speak. And so we're really talking about the advent of autonomous flight, which that's an area, Kyle, that you spend a lot of time with. So Kyle, what is your take on what's happening on Mars and how that relates to what you do? And tell us a little bit about Cherokee Nation and what that is.
Sure. Thanks, Vince. Actually, my interest kind of is the other side of Scott's point on this. Is I want to be able to push the button and see robots go do what they can go do. So the autonomy behind this, just like autopilots and where we're going to with aviation, I think is really cool. my background, I was a math computer science guy in college. Wasn't a pilot. I knew, like I said, I saw first shuttles launch when I was a kid. So I knew I wanted to be in aviation and aerospace, just didn't really know how all that would work out. And so everything has just kind of come together over the last 20, 25 years. And here we are now where when I was working at NASA Dryden, now NASA Armstrong, back in the late 90s, we were talking about a Mars rover or a Mars airplane at the time. So to see that now happening, I'm looking forward to next week. And I was talking to my wife last night of, the question is, do we want to get up at 3:30 in the morning on Monday morning, Sunday night, and watch it live? And the plan is probably yes. I'm going to be getting up and going for that, because whether it's 20 seconds, 30 seconds, the Wright brothers started it all here in North Carolina with 12 seconds. So if we can get 20 or 30 out of it, it'll be worth it.
So you're close to home.
I am.
The kitty hawk.
Everything you could ask for. I mean,
yeah, I didn't think about that earlier, but because I knew you were in North Carolina. But yeah, great point.
Yeah, less than 3 hours, I can be over there on the birthplace of all of it. So not to bash the Ohio guys at all, but I got good friends out there in Dayton, of course.
All's fair in love and war in aviation, right?
In aviation, exactly. Cherokee Nation's great. We support our federal agencies with program management, unmanned systems support. So working with with NOAA, we do a lot of activity there, both on the operations of unmanned systems, both airplanes and maritime vehicles. But then also on the data analysis on the backside, doing weather analysis and working with some great scientists on those programs at multiple federal agencies. I'm specifically supporting the Department of Homeland Security with unmanned systems integration. A couple of years ago, we were doing tunnel robots, including flying drones into tunnels to support kind of investigation on what's going on there. And now we're supporting the integration of 6 autonomous maritime vehicles, so surface boats that can also dive to support Coast Guard, pollution response activities, fishery protection, and then some law enforcement that can put up borders and run kind of multiple boats working together in collaboration. So
yeah, one of the things that I wanted to talk about having both you and Scott on is just what you said. All of the and we talked about this a little bit, all the various applications of drone technology and unmanned. I mean, you just said something that was interesting to me. So you use drones to fly in a tunnel, which they have to be, that means that they're totally autonomous because you can't really get a good signal through a tunnel, correct?
That's 100% correct. It's got to understand its situation. And then understand its path and where it's trying to get to. So, and then also work with, we didn't quite get there, but working with a ground robot to collaborate on how do we accomplish this mission best.
Wow. Yeah. So I guess the point I'm making too about is just to let the young people watching realize that there are so many different variations of opportunities. And the other thing I was going to say, and both of you can chime in on this as you will, you tended to, at least I'll speak for myself, think of drones before talking about the application stuff as just kind of a fun thing. Something, everybody was buying their kids' drones and the big kids are buying themselves drones and that type of thing. But, and now the emphasis in the last several years, maybe 10 years or better, has been on application. And both of you have a lot to experience with that, and a lot to say about that. So you want to share your thoughts with me?
I'll tell you, one of the biggest concerns that we have in our Department of Flight that we want to impart to students and anybody we reach out to is that component of aviation that we take for granted going through our aviation training, and that's aviation safety and human factors. Those are things that younger folks may not really kind of have that background knowledge of. And then when you run into a wire or a telephone pole or a house, oh, oops, darn, I'll have to get a new blade or whatever. But what they don't realize is that the FAA rules, even at the age of 16, you can become a commercial drone pilot at the age of 16. That comes with
I did not know that.
A lot of responsibility comes with that. And when you're around an airport, if you're flying as a recreational pilot, you still have to follow the rules. You still have to make sure that you stay within line of sight of your aircraft. I mean, there are FAA rules out there that people just don't know about. And all of that plays a part of, aviation safety, and really reducing that risk, and staying out of trouble, therefore.
Yeah. So no, that's a great point you make, and a great analogy, because to be a recreational or private pilot on up, you have to follow. So in fact, that's the FARs. That's a big piece of it. Is that in the process of being developed and created for unmanned aerial vehicles?
Which is that?
In terms of regulatory and
Part 107 and Part 101, 100. I mean, there's a lot of regulation out there that people just don't know about. You get a drone and you go out and you start flying it, and you fly over people. That's against the law.
Right.
Flying at night. You can fly at night now. Well, this month here, the rules are changing. So you fly at night, you got to have a strobe on your aircraft. But there's still stipulations. And if people don't know that and they go out and fly, then they can, get in trouble. And it's really, the components of aviation safety are there for a reason. When you look at what they're doing with Ingenuity, aviation safety is built right into the processes and procedures that they're going to use to get that thing out and fly it. Right. You don't want the Ingenuity to run into, the Mars rovers, right?
Right, exactly. And they talked about that. They talked about when they first launched it. First of all, that was a lot more complicated than I even thought it would be, in terms of how they had to drop it down step by step. It took several several Mars days to do that, and then power it up to stay warm because of the temperature going below 130 degrees, 130 degrees below zero, and things like that. And so, there are a lot of factors in there, but the other point, to your point, is the safety factor and safety margins. Once it starts operating, that it doesn't do something to damage the rover and things of that nature. So it's far enough away. So if it malfunctions, the malfunction won't damage anything. So I think your point's well taken about that. Let me ask you, Scott, about Embry-Riddle Aeronautical and the program that you guys teach in terms of unmanned aerial systems, vehicles, and that type of thing. So a young person, for example, in high school, that is thinking about wanting to actually study that. So unlike a lot that go to learn how to fly a fixed wing or helicopter, or get their aeronautical science degree, or whatever the case may be, what is it that what should their expectations be to come into a program like yours?
Well, we do have dual enrollment, which enables high school students to, concurrently take a bachelor's degree course.
Oh, wow.
As they're still in high school.
Okay.
They're, eligible to just jump right in online. We have undergraduate certificates, we have full degree programs, and we have professional education. I've not had any young students in the pro ed side, but we do have the UAS programs in all of those venues, all the way up to the graduate level.
Okay.
And we are starting to integrate flight. We're about ready to do remote check rides, where we could do it using Zoom and do a check ride. As a matter of fact, one of Kyle's former employees at NC State did that exactly, a remote check ride with me. He videotaped it and sent it to me. But now we're going to get into where we can do it live, so that, we could do an actual check ride over Zoom, so to speak.
Wow. So Kyle, you're familiar with that he's doing, huh?
Yeah, we've been tracking this for a long time, working with the guys at State to build up that program. So one of the interesting things, one of the best things about Embry-Riddle is they worked real close with AUVSI to develop the Trusted Operator Program, to look at how do we certify and have a consistent method for evaluating pilots. And it's been a great program. To know the guys at NC State are still doing that. And actually, to kind of build on your question there, Vince, too, one of the things we looked at NC State was how do we integrate unmanned systems across disciplines? And really, aerospace engineering is a great side of it to say, how do we build them? But it's just as much the programming when you're looking at the computer science, that's there. The pilot side, the operations side, then starts opening up, well, how are we going to use the data? And so that's where natural resources jumped on board real fast, working with folks there on how to do the data analysis. Our agriculture folks jumped on it, and really it started spreading across campus. Our industrial engineers, really there was a lot of very few disciplines. Even our archaeology department started using it for how do we go out and do further analysis of old ancient sites that they started doing research on. So it became this kind of pervasive of, okay, we've got these tools now, and everybody kept calling our office to say, how do we fly legally? Who's allowed to do this? How do we actually use the data appropriately? So
to Scott's point,
it was a great resource, and having that knowledge, that bigger picture on this, Embry-Riddle's done a great job with it. I think we did a pretty good job at NC State too.
Yeah, I'm glad you brought up about the different disciplines, because I think we talked about it before, and I've talked about it on the show before, that a lot of people have an interest in aviation or aerospace, but they automatically think you have to have, for example, an aerospace engineering degree or something like that. And they don't realize that there are other opportunities in your other disciplines and area of interest that still tie you in. So you can be an archaeologist and still be tied into aerospace, as an example, because exploring another planet, obviously there's an archaeological factor or a geological factor or et cetera, a microbiologist and things like that. But Kyle, you just said something that I think also, I wonder how that affects you guys. So somebody, for example, wants to use it for archaeology. That tends to be a very delicate area in terms of exploration. In other words, if you use a drone, you don't want it to disturb what you're looking at. And so does that come into play with you guys in terms of developing and design and that to make that adjustment for a particular discipline?
So most definitely it comes into that mission planning of, okay, now what is the right way to approach this problem? And that's really where I've loved working with drones and all kinds of robotics, because you've got to evaluate, you've got to understand not just the technology, but now how are we integrating this into the environment we're going to go use it. So whether it's archaeology and exactly that of, okay, we've got this third dimension that we can go access to get better pictures, to get new data, to get a new perspective, especially as we look at some of the new LiDAR technologies that can allow things to pop off that we couldn't see from the ground or close to the ground. But a better example on that one is some of the things that USGS, the Geological Survey folks, have used drones for flying over endangered species. Sandhill cranes, for instance, are really skittish. But if you let them bed down at night and they all just kind of hunker in and they get all settled, you can go fly over them at night. Infrared images pop out. You can see exactly where they are, and they don't really care that you're flying over it, and they don't disturb, they don't scatter, so you can get better counts that way. So a lot of that kind of biological stuff has drones kind of opened up more windows for capturing that information too.
I got to ask both of you guys, does a program like Ingenuity help you guys with what you do in terms of giving more visibility in a very positive way about UAS?
Certainly. With the small UAS, which essentially Ingenuity is, the small UAS rules anything under 55 pounds with the FAA. But I think that really as a multicopter, it's using the counter-rotating system. We don't have that a lot on commercial off-the-shelf products, but it's a great way to educate students on the different types of rotor systems that are out there, a quad, a multicopter, and having that coaxial system that the Ingenuity has, where both props are turning in the opposite directions. For an aerodynamics discussion, it's beautiful, because then you can talk performance, and that gets you into discussing, the battery power and how we're going to keep that battery charged when we're going to use some of that battery power to heat the battery to keep it from failing. Wow, what a bunch of great problems to have a good discussion on.
Sure, absolutely. Kyle, how does it help you guys?
Yeah, I agree with Scott completely on that one. And kind of even looking back, it shows a technology maturation that the ability just to do this, to have the connectivity, to hopefully see it stream pretty close to live when it does fly is going to be really cool, because we couldn't do that exactly when the Wright brothers were around. So we think about that. We think about the technologies that are going to come off of this to show that autonomy is there, that we can expect the aircraft to do what it's going to do. Just like we're taking Perseverance. We've learned so much from Perseverance, Curiosity, Spirit, and Opportunity that we've gotten to this point. So if we look at other NASA spinouts or other technologies that are directly attributed to our space exploration, looking at Velcro, microelectronics, all these different things, by pushing that boundary, it's benefiting the rest of society here. So I'm super excited for it. And for us, I think we'll be working directly with more of the folks that are pushing that autonomy and working on the programming, because these lessons all get shared. It's public research that's doing this.
Yeah. Kyle and Scott, one of the things young people are challenged with is trying to figure out what they're going to do in life. Scott, you touched on it when you said that you had your first helicopter ride, and even though you had already been in the Army, that was kind of an eye opener for you, and then you started focusing on that, and the rest is history to some degree, and we can talk about that. Kyle, you ended up doing what you're doing now in UAS, but I doubt that was on your radar, in high school or middle school or whatever. So how did you tell us about your path?
For me, I really like the problem solving. I like figuring out logic problems. So that's how I ended up going down the math path. Computer science is just an easy add-on. It really kind of focused on that logic. So for me, it turned into this. I'm interested in understanding problems, understanding the logic behind it, and now how do I translate that into something that's repeatable? When I was a young engineer, really on the software side, a little artificial intelligence company down in Atlanta was looking for a knowledge engineer. I said, that sounds pretty cool. What is a knowledge engineer? And it's exactly that. It's the understanding an operational environment, understanding how robots and even aviation systems, because at that time we were looking at Next Gen was just getting launched. So we were talking about ADS-B and this connectivity of aircraft into this modern world with very light jets and these kind of things that were coming online. And so we were going to program all of that logic that supports the safety stuff like Scott's talked about today, but also takes in all the other information through connectivity of weather, what's going on, traffic, what's going on, and then how do we make smarter decisions to help pilots that maybe don't have a lot of flight time. At that same time, we can look at that and apply that to unmanned systems and say, okay, well, how does the drone make its decision now if its pilot's remote? So for me, it was just a looking at how all these things come together. And so I've ended up with knowledge in my job title for a couple of times. And it was just a chance to work a little bit on the real side, a little bit on the research side, and just kind of apply it all together.
Yeah. Tell us a little bit about the Cherokee Nation and a little bit more about its history. Most people would associate that with what it sounds like, but it's kind of a unique thing in terms of what it's all about. So can you tell us a little bit in more detail?
Sure. So Cherokee Nation as a Native American tribe, we're the largest of the tribes. And then we started up this business support group probably about 15 years ago, 20 years ago, and primarily supporting casinos and running casinos. But then we also had this chance to develop business opportunities. We're primarily working with federal agencies. So we've got about 10,000 people spread across the country, supporting different federal agencies, doing a wide variety of work. Some of it's all IT, some of it's healthcare, and then some of us do these kind of unique special projects. It gives us a chance to kind of work on some really cutting edge opportunities. We're not an operational group, so we're not looking to be just drone flyers and drones for hire. We really like working on that program management kind of consulting side of what's the right way to do this? How do we pull in operational? So we've got folks that have military backgrounds, we've got engineers, we've got scientists, all within the family to help out and support these agencies doing what they need to do.
Yeah, 10,000 employees, that's pretty expansive in terms of what you guys cover. How does a person that maybe at school, maybe at Embry-Riddle or whatever, if they were interested in finding out more or interning or getting involved with Cherokee Nation, what would you recommend?
So our website, it's actually Cherokee-federal.com. Has a great opportunity to see all the different jobs that we've got opened up, all the different things that we're working on. Vince, I can make sure you get my list of unmanned systems for our specifically unmanned systems website that does a really good job of covering the different applications, the different technologies we're working with. Some of it has been underwater archaeological things, looking at shipwrecks. Some of it has been straight Department of Defense support activities too. And of course, what I'm doing with DHS is there. So really, we've got, like I said, we've got everybody. We've got scientists, we've got operators, veterans. So really, we look for the best of the best, and we look for people that have experience in operational environments as well as top scientists and engineers.
Yeah, great. Now, I want to be able to share that information with everybody, so I appreciate that. Sure. Scott, you were a Boy Scout back in the day, and you go from a Boy Scout to teaching as a PhD at Embry-Riddle. Tell us a little bit more about your path.
Well, I knew I wanted to go to college, but just wasn't sure I wanted to start right away. So I took a year off, and that's how I got the Army start. I knew education was something I was very interested in because I got along with kids real well, and really went down that path with my first degree in education. The Army was in the Cold War at the time, so once I graduated and went on active duty, training and education are intrinsically aligned, obviously. And then it was my last duty assignment. I requested to go to Embry-Riddle, having just finished the master's degree and ran the ROTC. And that's really what got me here. But I stayed in education. I stayed in training. My flight instructor on the civil side, the military side, actually, too. It just all kind of fit. And I would say that with the experiences that I've had and the opportunities that I've come across my whole life, really all play into what I'm doing today. And it makes it just that much more fun. You know, to me, this is what a great second career to have, is where I can help young people and influence in a positive way their step into aviation or just their relationship with aviation, and do it in the right way, giving them all the touch points that they need to use to make their own decision, which is something that I take really personally. As I get asked questions from students all the time, and I don't want to tell them what they should do. I want them to figure out what they should do. I want to give them the knowledge to understand what questions to ask, and then they can discover that on their own. And I think that's where sometimes in education, we kind of go the wrong direction. We need to enable that decision-making, that critical thinking, like Kyle's been talking about, where they're knowledge experts, right? So they have all the tools now to decide, okay, what path am I going to take? I really like this, so I think I'm going to go down this path, and it's UAS. And all right, I know now what I have to do to get there. And that's been my experience, how I got into aviation. So I think it's a good tool to carry on and carry forward.
Yeah, absolutely. Kyle, you've been in the education environment. You've been talking about that. You want to chime in on that a bit?
Oh, I'd love to chime in on that. I cannot imagine working in any other industry. Are there other places where you could probably make more money, maybe get more visibility? Probably. But aviation and aerospace has been fulfilling for me every day. So not to tell kids, here's what you need to do, but to understand those kinds of things about you, just like Scott just said, of what is it you want to do? What kinds of impact do you want to have? How do you want to see yourself? What drives you? And to work in this industry that is incredibly dynamic, has so many different ways we can touch people, and reach out and change things. And really, as we look at aviation going forward in the next 10, 15, 20 years, where kids today going into college and coming out of college are going to have kind of that same path of what have they done over the last 20 years. It's really, really exciting as we look at how connectivity has changed in the world, how the world's going to continue to get smaller as we integrate these unmanned systems into different perspectives. And the connectivity to reach the moon, to reach to Mars. All of this is going to happen in this industry over the next 15, 20 years. So I could not imagine doing anything else. So that's always my recommendation. I've had some great students that have come out. They're pilots. They're out there doing their thing now. They're loving it. And I've got engineers out doing their stuff. So it's always rewarding to just kind of talk and hear where they're at and what else we can do together.
Yeah, point taken from both of you. And it applies to everything. I mean, we're talking about unmanned systems and actually the technology. I mean, yesterday, SpaceX launched a Starlink in orbit. And I watched the whole thing. And yeah, you think I'd have other things to do during the day, but what can I say? But anyhow, I was watching it, and the thing that fascinates me is they're doing things manually, and then they tell you, okay, now the rocket is on its own, like 30 seconds before launch. It's on its own. It's autonomous now, so they're watching, and they'll see if they see any alerts, but it's on its own. It's going to do everything from that point on. Including dropping the first stage and then going into orbit. And then, a little bit later, you see it launch the satellites. And then the satellites are going to find their orbits and then, of course, become operational, as they put it. And that stuff is just amazing to me. And how that all, as you said, all of it, how it connects and things like that. So.
When you think about the permanent presence we've had now in space for over 20 years, somebody's always been up there at one of the space stations. That's super cool. And now how we've almost had robots consistently operating on Mars for almost 25 years now. What are we going to do? I mean, that's just in the last 20 years. So what are we going to do with another 20? It's almost hard to think about.
We're going to get a 787 that's autonomous going from Los Angeles to Hong Kong autonomously.
No, definitely. Full
of passengers.
Yep.
That's where we're going.
Yeah. Do you see that with or without a backup pilot on board?
Yeah, probably we'll have a backup pilot for the first, few years and until we don't need it anymore. It was always fascinating to me to see 2001 Space Odyssey. If you remember the scene where Pan Am is sending the shuttle up to the big space station in the sky, and they had pilots on it, but that was done in the 60s. And here we are, now we can do it autonomously. We didn't quite get that right, but we got a lot of other things right from that, that early dreaming that we've done. It's just fascinating to see how that turns into technology. The small drone is a great example.
Yeah. The small drone is a great example. And then I'm thinking of the bigger drones. So now there's urban mobility. That's the big buzz and talk and effort and that type of thing. I'd love to hear you guys' perspective on urban mobility and the future of it, what you see happening with it. Talking about the things that you just said, the autonomy of a larger aircraft being able to take people places.
Well, we've had a lot of development, from the autopilot. Let's look at a helicopter where you have the ability to stop at a point in space and just sit there and hover with a press of buttons. We've had that for 20, 30 years, but now we're going to be able to get into a 4-place aerial vehicle, press the button on where we want to go, or we've done that on our phone with Uber Air, whatever. We get into that aircraft, it takes off and it flies us there. No pilot. Scary maybe for some, but there'll be brave souls who will test it out and they'll do just fine because the FAA will not let them bring that to bear unless it's safe. So again, I go back to how important aviation safety is from every single aspect that we've been talking about. For the engineering side, the infrastructure side, the air traffic control, that unmanned traffic management, the UAS version of ATC, And that, the FAA is throwing a lot of money at to research and make sure that we get it right the first time. And other countries are just diving in. But I think that we're probably going a little bit slower than we should, but darn it, we're going to get it right. So,
and you're familiarizing your students with the very thing you're talking about, which also brings to the point that means there are opportunities in the FAA for careers.
Yes.
And there's going to be, as this grows, both with the smaller UAVs and the big ones, the urban mobility stuff, it's opening up a whole new. It's opened up. I'd say it like it's past tense, but it's current. It's opened up a whole new category of opportunities in that area and of needs, I should say, in that area. So, yeah. I'm sorry, Kyle, you look like you were getting ready to say something.
Yeah. So actually to that point, right? So having the engineering background is great, but also people that can understand and read policy. So even a lot of political science folks are even kind of looking at this industry to say, how do I get involved here? Because they like to read, they like to write, and be able to pull all that together. That's typically not an engineering skill set. It's great when they can, but people that can do that one has been. I've had folks that have come through and students that have come through that are now working that side of things too. One of the other perspectives as we look at kind of where urban air mobility is going, I'm playing around with a side project now of, well, what would society look like if we'd have flown before we built cars? If we'd have been able to build airplanes before we built cars? We've got this infrastructure now of roads and everything else. Well, maybe we would have just had railways across the ground. And if we'd have gotten access to the air, we would have built the same safety. We would have built the same infrastructure. We'd been able to build up this view of connectivity where maybe urban centers didn't become so dense, and we still had this kind of reach across.
That's an interesting perspective.
It's a side project I'm working on. We can talk about that later.
Talking about the Jetsons.
Exactly. And kind of back to the last point, right? So Elroy wasn't a pilot, but he was definitely one of the first unmanned package delivery that was every day getting shot out of his little pod to school.
No, that's interesting though. That's an interesting study and perspective to look at with that. I was going. Oh, so I had a couple things I'm thinking all at the same time. But let me go to this. Let me go to you, Scott, in terms of the helicopter aspect of things at ERAU. So you were involved with the development of the helicopter program at Prescott, right? Yeah. And you would think that would be a natural thing for them to have a helicopter program, but it was actually something that had to be introduced and developed. Can you tell us a little bit about that?
It was a lot of fun to do. Being there stationed by the Army, I wasn't an Embry-Riddle employee at the time, but they came over and said, hey, you're a helicopter guy. How about helping us figure this out? So we let the students drive the train. We said, okay, here we're going to have a meeting about helicopters and whether or not we should have a program. Here's what it would entail. Are you interested? And if you are, then the students need to get together and push it. They did in spades, and we built one. The University of North Dakota had a program for decades, long time, since the 80s. And Embry-Riddle did not. And Embry-Riddle did not because our niche was airlines, to get our students ready for the airlines. And we really did that well and still do. However, the interest was there. And really, once that program got in place, then it was just a few more years when we got into UAS. But yeah, my 8 years at the Prescott campus was mostly engrossed in running the ROTC program till I retired, and then just stepped across the hallway and had another office to run the helicopter program.
Yeah,
very fortunate, very lucky.
Yeah. No, I just wanted you to be able to share about that because I thought it was pretty neat what you get an opportunity to do. So, with all that we've talked about, and you guys have talked a little bit about the future of what you're doing and the systems and that type of thing. And I know one of the things I was going to actually just mention it when you were talking about different disciplines, Kyle. So I had a show couple of months back, and I had helicopter pilots, one from each branch of service. And, you know, the thing was, I said, okay, these are all helicopter pilots, happen to be all female helicopter pilots, all really doing well in what they do. And they were all flight instructors also in the various branches. But when I was looking into their backgrounds as we were talking, one of them was a history major, one of them was an English lit major, one of them was a microbiology major, but they're all flying helicopters and having a good time with it at that. And I found that really fascinating. I thought that was pretty interesting. So kind of it triggered me a little bit when you said it. I'm using one of my kids' term, trigger. When you said it, because you know, it's a great point. If you're a good writer, or if you have those skills that lean towards law or regulatory or whatever the case, or operation, or the ability to write an operations manual and things like that, there again is another aspect of the industry. And I would imagine, so you've dealt with a couple of universities, Kyle, and then you at ERAU, Scott. Are those part of the curriculum too when you guys are you know, when these kids are learning in your programs?
So for the work that I've done, that has always been a piece of it, of being able to reach across different departments, support the different disciplines on how they want to use the technology. And really that's why at NC State, we never built a UAS program per se of a degree program. It was always, let's work with across the different departments and support the integration that way. They're doing some really great things now in the electrical engineering, working with National Science Foundation on some of their research. But really, I think most of the departments across campus wanted to use it. And that's really kind of been the cool thing about drones over the last 5-10 years, has been this democratization of this access, this now I can buy this tool, I can access this tool. How can I use this now in an everyday thing? And we're seeing those everyday operations with package delivery right now with medical supplies. We're seeing surveyor construction companies. These really are just new tools in their toolbox, and they're getting used every day. And that's really, those of us that have been doing this for 15, 20 years knew that was going to happen one of these days. I won't say I knew it was going to be quadcopters, but it's been coming. The technology has been maturing to this point. And now it comes back to the points that Scott was bringing up of how do we make sure they're always safely used, but then how do we keep making them smarter so that we can start programming some of those laws and they understand that safety built into it as a robot should. So, and then of course, back to the real edge of that is now if the robot and the human are working together, how do we build that bridge so that they understand each other? And that's really where there's still a lot more research to be done.
Sure.
I don't think,
Scott.
I don't think we've found the last mission that we can do with the UAS yet. I think we're still exploring. We're pioneering this thing. And so to the listeners, yeah, I mean, my undergrad degree was education. I ended up there, but that wasn't what I thought I was going to do. However, when you look at the breadth of aviation, aerospace, aeronautics, there are so many things, different things that relate to it. Last summer up in Oregon, I got tied in with a beaver conservancy, and what they're trying to do is check out the beaver habitat in certain waterways. And we used a drone to map it out for them. A week and a half later, I'm helping a farmer trying to find a problem with a bug that he has on his plants using a drone to see if we can figure out using orthogrammetry and NDVI's data of how to, you know, find out where those plants are problematic. I mean, it's just, it keeps coming, and there's new things every week that we can do, you know, and the technology just keeps advancing at a rocket speed.
I think that's a great point. I have a question. What's an NDVI?
Non-differential vegetative index.
Okay.
I'm pretty close. It may not be totally right.
I didn't mean to put you on the spot, but I was like, oh, okay, what's he talking about?
Yeah, that's essentially where you have a sensor that's got a red, a blue, a green, a near IR, an RGB or standard camera,
Right.
and it can really check the health of the plant and soil conditions.
Gotcha. Yeah. And that goes to what you were talking about too, Kyle, in terms of application, all of the different things. You mentioned the tunnel. What are some of the other areas that you guys have been working with?
So we've done the weather thing with NOAA, a lot of flying into hurricanes, around hurricanes, looking at those predictions to better take that science, take the data out of that.
I'm sorry, not to interrupt you, but to interrupt you. Flying a drone into a hurricane?
Oh yeah.
How does that work?
So that pushes the autonomy and the autopilot on the aircraft, but that's been done now for several years of flying them in, flying them out. Other universities have done things like flying into the boundary layer winds of tornadoes. If you build a rugged enough system with a really good autopilot, you can do some really, really cool things, like Scott's saying too. And it's all a question of where's your imagination, how much do I want to do, and that's where we're opening things up at. So yeah, we've done some of this directly with NOAA. Like I said, with our stuff with DHS, we've flown into tunnels. And next, we're going to be doing some of this manned machine and actually multiple machine operations. Hopefully working with some of our unmanned boats that we're testing next year.
Yeah, and the one other thing about flying into a hurricane or a tornado, I guess it's about the entry point and exit point.
It's about mission planning of where do I want to go in? How do I understand enough of what the environment is, what my capabilities of my aircraft are, and like the guys at UC Boulder that have flown into the boundary layers of tornadoes, they built 3 expecting to lose at least 1, maybe 2, and they didn't even lose 1. They were able to do everything they needed to do. So it comes back to the engineering and science, got to build it strong enough.
Yeah. As we wind down and start wrapping up, one of the areas I wanted to ask both of you about was the Association for Unmanned Vehicle Systems International, AUVSI, which is actually played a large role, along with HAI, Helicopter Association International, of me getting in contact with you guys and being able to have you on the program. So can you tell us a little bit about that association, what it does, and how important it is to the industry?
Well, I think from my perspective and what we do at Embry-Riddle Worldwide, we saw their Trusted Operator program as the best available aeronautical knowledge, professional processes and procedures, and structure, really, standards it just doesn't exist. The FAA has the Part 107, it has some rules, it's very limited. That aviation safety piece that we've been hammering home, you've heard Kyle mention it's all in planning. About how many times, Kyle, just in this talk, and that's what the top program does, is it gets you that level of where I would say you're on par with a commercial manned pilot. So a Part 61 license that an airplane pilot, even a 135, a commercial operator would have, but for the UAS side. It's the only thing that's out there that comes close.
Gotcha.
Yeah, I'm a big fan of AUVSI. I've been a member and engaged with the association for over 20 years now, since I started in this industry. They've done a great job with the top program over the last 5 years. They've also got student competitions for robo subs, drones. They embrace it, working with companies like Sea Perch. So they've got a lot of different components, a lot of different ways to play with the education and the foundation on that side of things. So the association is great. It's the industry that, like I said, I've kind of grown up within. It's where my career has kind of been built around. Great people. Great engagement, and they connected us here. So I'm always appreciative and enjoy the chance to kind of spend time with them.
You guys both talked about the future to some degree. As we start to wrap up, what recommendations do you have to the next generation in terms of this aspect of the industry going forward?
Research. Get out there and dig stuff up. You young folks are so much more adept at it than we were when we were your age, because you have the vehicles to do it. It's at your fingertips, and it's exciting just to be able to do things like this. And Vince, thank you very much for bringing this to to the young folks out there, because now they know more. Now they know, they're probably writing notes down. I want to go look at this, this, and this. And that's exciting that their interest is going to carry forward. And
right.
We're here for you.
Yeah. Kyle?
We're at a really exciting time in history. We've got all these really cool technologies that are coming together now, and really we're only constrained by imagination. So just like Scott just said, right? Go do research. All this information is available. You can go learn anything, but push yourself into that unknown. Push yourself into how can I figure this out? What has been done, or what can I do that nobody else has ever done? And push yourself into the world of, I need to go find people that can guide me, but find people that don't have answers. Know that there aren't answers out there if you're going to go get out there and get on an edge. And live it on an edge. There's so many ways to do that in the aviation world that I think there's a great opportunities here. But definitely push yourself and push yourself into that world that you're uncomfortable, because now's a great time to go figure things out.
Couldn't have said it better myself. We are about out of time. Last words? Anything else?
I appreciate the time.
Yeah, well, we
you,
appreciate
everybody.
the opportunity. I appreciate the opportunity to have both of you on and to talk about it. Looking forward to, I will be up in the wee hours, whatever time it is that the helicopter flies on Mars. That's a once in a lifetime thing to see a first like that.
Yep.
And so I think it's really important to be able to, at least for me, to personally experience that. So, and say, yeah, I remember when. I'm running out of I remember when time. No, I'm just kidding. But I do look forward to that. I'm also looking forward to seeing when things open back up, more kids get into remote operating of drones and things like that, and model rocketry and things. I think those are great for early learning. I'll put it that way, and getting them interested in it. Wish you luck with your son, who's he's like early middle school, and he's already into this stuff.
That's it. Yep. We're going to go out and go launch a couple this weekend. So it should be fun times.
Yeah, a lot of fun. And Scott, you have a daughter that's in aviation.
She is a Scan Eagle drone pilot, deploying in a week and a half.
Okay. And she's enjoying that?
She loves it.
Yeah.
She loves it. Never
Did you
thought
see
she
that
was gonna
coming,
get
Scott?
What's that?
Did you see that coming?
No, I had no idea. And then all of a sudden there it was, and she was working for the company, and she goes, well, yeah, there's a little bit of that big money aspect of it, but the, traveling, which she did growing up because we were in the military and moved around all the time. And,
right.
And so that bug stayed with her and had an opportunity to go fly it. And she said, I am hooked.
Awesome. Guys, I wish you both the best. And appreciate you again being on All Things Aviation and Aerospace. I'm Vince Mickens from the Private Air Media Group, and I'll see you guys next week on another show. Thank you for joining us today.
See y'all.
And please subscribe to YouTube. And I've been told, my kids are like, Dad, you got to remember to tell them. You got to tell them subscribe. Kids still influence you, right?
As it should be.
As it should be. Take care, guys.
Take care.